Alright students, so I wanted to make a video on angle relationships. And so if you note, the words angle and relationships are making an angle, and so is my dog, Boko. Her feet are making an angle. I don't know why she sleeps like that, it's kind of weird. But you can see her legs are crossing and they're forming angles. So that's what we're going to talk about today, lots of different angle relationships. So here's the first one, very important, are supplementary angles. So if we have a straight line here, we have right here, and another like ray is coming out of here. So these two angles here are supplementary. Basically, what does that mean? Supplementary angles are two angles, can't be more than two, that sum to 180 degrees. Now they don't have to be connected. So for example, like I could move this out, right? And you could have something like that, and they're also supplementary. So if they're connected, that's a special type of angle, and that's known as a linear pair of angles. So if they're connected or adjacent to each other, they're known as a linear pair of angles. So I would definitely like you to take notes on the guided notes that we gave you. So write that down. I think you already have the definition for supplementary angles and the diagram. So just take notes along with the video. So let's label some points here. So I used JETS. They're currently horrible, but you know what? Maybe somebody in the future will be watching this video and the jets will actually be good. Right now they're terrible. So anyway, so we have these two angles here. We have angle JET and angle SET. So those are the two angles right there. I just highlighted them. So angle JET is in blue, so that's this angle here, and then angle SET in red. So they have to add up to 180 degrees. So if we remember, an angle is just the amount of turn, and also remember that we always name our angle with 3 points usually, or sometimes you'll see we name it with the numbers. So if they're named with points, E goes in the middle, right? That's the vertex. So JET and SET. So if there's a complete circle here that's 360 degrees, an angle is just the amount of turn, right? So this angle here is what fraction of that circle is in 360 degrees. So I'm gonna go ahead and erase that. So you can see this is just now a semicircle, it's half a circle. They have to add up to 180 degrees. So for example, if this angle is 40 degrees, then that would have to be 140 degrees. Also, one other thing I wanted to point out. So if you see this M in front of the angle, that means measure. So you might want to write that down too. So the M in front of the angle means measure. We'll talk a little bit about that in a sec. So let's talk about vertical angles now. So vertical angles are congruent opposite angles formed by intersecting lines or line segments. So if you think about Oko's legs, they were crossed, they were forming congruent angles. And so the opposite angles we're talking about, so if we labeled some points here, ANGLE for angle. So these angles here, the ones opposite each other, so not the adjacent ones, the ones opposite each other. So if we look at those two acute angles and the two obtuse angles, they're going to be congruent to each other. So ANG is congruent to LNE. So let's write that down. Or we could say that the measure of angle ANG is equal to the measure of LNE. I'm going to talk about that distinction in a second. So we could also say that these obtuse angles up here, so ANE and LNG, are also congruent. So it's that amount of turn of the same. So the difference between these two symbols, one is congruent, one is equal. We talk about congruence when we talk about the shape of something. So what size is the shape? So if they're the same size, then we actually say that they're congruent. If we're talking about the actual number associated with the shape or the angle or the line segment, we would use an equal sign. So here we're just talking about, and it's a subtle distinction, so you're going to see both of them. Parallel lines cut by a transversal. So let's look at that now. So I believe you have the definition of transversal, and a transversal is just a line. Oh, first of all, sometimes you'll see these arrows marking parallel lines. So don't assume anything's parallel unless they tell you it's parallel or if they have little arrows marking that they're parallel. So there's a transversal, and I think you have that definition. It's just a line that intersects two or more lines. And again, a transversal doesn't actually have to intersect parallel lines. It could intersect non-parallel lines. So let's go ahead and number the angles this time, because it's a little easier than dealing with a bunch of points. So we have 1, 2, 3, 4. We have those 4 angles, and then 5, 6, 7, and 8. So we're going to talk first about corresponding angles. So corresponding angles, I think you have that definition too. Are there angles that lie in the same position? So when I think corresponding, I think corner. Are they in like the same corner? And so what we're going to see is we're going to actually like trace these angles and slide them down, and you'll see that 1 ends up on top of number 5, and 2 ends up on top of 6, 3 on top of 7, and 4 on top of 8. So if they're in the same relative position, that means they're corresponding angles, and they're actually congruent to each other. So you can go ahead and highlight one example, like angle 1 is congruent to angle 5. Those are corresponding angles. So there are also 3 other sets of corresponding angles. There's angle 2 and 6, 3 and 7, and 4 and 8. So those are all corresponding angles, and they're all congruent to each other. All right, so let's take a look at my favorite one, my favorite set of angles. They're known as alternate interior angles. So let's take a look. So what does that mean, alternate interior angles? They're basically a set of congruent angles that are between the parallel lines on opposite sides of the transversal. So the interior, and you can go ahead and highlight this as well, that's the inside the parallel lines, right? So in between the parallel lines, that's what we mean by interior. And then alternate, we mean on opposite sides of the transversal. So for example, 3 and 6 are going to be congruent alternate interior angles, and then same with 4 and 5. And you'll notice it makes a kind of cool Z shape, right? So 3 and 6 form congruent alternate interior angles, and then say so 4 and 5 would create like a backward Z. So we can take a look at that. So yeah, there would be that backward Z. So angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. So let's take a look at alternate exterior angles. So alternate exterior angles, so I'm kind of plagiarizing myself here, between the parallel lines and opposite sides of the transversal. No, not between, outside the parallel lines. So here, for example, that's the exterior that I've highlighted in green. So you can go ahead and highlight that as well. So that's on the outside, right? And then I want on opposite sides of the transversal. So for example, angle 2 is congruent to angle 7. So they're on opposite sides of the transversal on the outside of the parallel lines, and they're known as alternate exterior angles. So we have angle 2 and angle 7, and angle 1 and angle 8. They're congruent alternate exterior angles. All right, so let's take a look. I know this is a lot. There were a lot of terms, new words, and stuff like that, but I want to just summarize really quickly. So basically, when we have parallel lines cut by a transversal, and we learned about vertical angles, right? So we have these like opposite angles here. So for example, say 1 and 4 are going to be congruent to each other, and 2 and 3 are going to be congruent to each other. But we also learned about alternate interior angles, alternate exterior angles, supplementary angles, lots of things going on, right? Let me just sum up. So just write this down. All acute angles are going to be congruent. So whenever you see parallel lines cut by a transversal, all of the acute angles are going to be congruent. And same goes for, just two intersecting lines, right? So if we have just these 2 intersecting lines here, the 2 acute angles are going to be congruent to each other, and the 2 obtuse angles are going to be congruent to each other. So if you can spot what an acute angle looks like, and I'll show you some examples of how to do that, or an obtuse angle, you know they're congruent immediately. What else do we know? Well, all the obtuse angles are congruent. So all of these acute angles, so for example, 7 and 6, 7 and 2, 3 and 6, they're all congruent to each other. They just have different names, like are they alternate interior angles, are they alternate exterior angles, or whatever. One final thing I want you to note is that acute and obtuse angles add up to 180 degrees. So if you take any two, like any pair of one acute and one obtuse angle, or here's an acute angle 6 and an obtuse angle, say 4, they're going to equal 180 degrees always. So they're going to be supplementary angles. So that is, like, in a nutshell, what you need to know about parallel lines cut by a transversal. So, for example, if you know one of these angles, if you know angle 1 is, say, 100 degrees, you can find all 7 remaining angles, because if that's 100, that has to be 100 degrees. These have to be supplementary, so that would have to be 80 degrees and 80 degrees. And then you have congruent alternate interior angles. You can work your way around the diagram, and all of a sudden, because you know one angle, you know all 8 of them. So I hope this helps. Please let me know if you have any questions, and we'll go over this some more in class.